Let's look at some extra practice problems for solving one-step inequalities. And we'll just start with the basic ones that we're just going to do some basic adding, subtracting, multiplying, dividing. So we're going to use inverse operations. So for this first one, our goal is always to get the x by itself, to isolate the x or whatever the variable happens to be. Right now, they've added 2 to that variable. So we have to undo that, do the opposite. It's like we're going backwards. If I added 2 to something, to undo that, I need to take away 2, or minus 2. But we have to still keep this balance. So whatever we do to one side, we have to do to the other. So I'm going to minus 2 on the other side also. We can check to make sure we did the right operation. When we're adding and subtracting, these should always make 0. And a positive and a negative 2, those do make 0. And we don't have to write x plus 0, because x plus 0 is really just x. I'm going to drop down the inequality sign, which is greater than, and 7 minus 2 is 5. Then I can use inverse operations again on the second one. Right now, they've taken away 3. Well, to do the opposite of that, I need to give back 3, or add 3. Again, we have to do it to both sides. And by both sides, I mean, let's imagine a dotted line here. The left side and the right side is what I'm talking about, both sides. So when I write this plus 3 here, I want once on the left and once on the right. You don't want it to be twice on the same side. And we want to check to make sure we did the right operation. Negative 3 plus 3, yep, that's 0. That's what I want, so that it goes away. Is less than or equal to, and 9 plus 3 is 12. Let's look at some similar ones. The x is not always going to be so nice and neat on that side. Maybe I have, well, let's keep these same numbers actually. I can keep that same equation that I had before, and 2 plus x is greater than 7. This is the exact same thing that we just had above. I've just switched the order. I've used commutative property. So this is a positive 2 here. So to get rid of that, I would want a negative 2. Because again, our goal is to make 0. And a positive 2 and a negative 2, that makes 0. And again, we have x is greater than 5. Let's do the same thing for this next one. I've got a negative 3. Because that minus sign is the same as a negative 3. I've got a negative 3, and I had a positive x. So that is the same thing as what we had above. If I change that back up here, I had a minus 3 here. So there was a minus sign in front of the 3. There's a minus sign in front of the 3, but it is the same thing as a negative. So they're interchangeable. And then again, I want to make 0. So I have a negative 3. To make 0, I need a positive 3. So on both sides. So this is where we get confused a lot of times. We see, well, there's a plus sign here. I want to subtract. The plus sign is attached to the x. This negative or minus sign is what's attached to the 3. So that's what we need. And that makes 0. So then I have x is less than or equal to 12, just like we had before. Let's quick look at some with multiplying and dividing. So if I had the problem 3x is less than 15. Anytime we have a number right next to a variable, there's really a multiplication sign. We just don't tend to write it. So 3x means 3 times x. So then when I do my inverse operations, the opposite of multiplying is to divide by 3. And again, we've got to do the same on both sides, left and right. And then if we think back to fractions, 3 over 3 as a fraction, I can divide them both by 3 and get 1 over 1. Or if I put it in calculator, 1 divided by 1 is just 1. Or 3 divided by 3 is 1. So that tells me that when I divide by 3 here, those turn into 1x. But 1 times anything, like 1 times 5 is 5, 1 times 9 is 9. So 1 times x is really just x. We don't have to write the 1. Is less than, and 15 divided by 3 is 5. Looking at a division example, if I have x over 4 is greater than or equal to 6. So this fraction here, this x over 4, fraction bar is really just a division sign. So the opposite of dividing by 4 is to multiply by 4 on both sides. And when I'm multiplying fractions, I put 4 over 1. But what I really end up having here is this is essentially 4 over 4. And we just said that anything divided by itself is going to be 1. So this makes 1x. I don't have to write 1, so I just write x is greater than or equal to, and 6 times 4 is 24. The only other thing we have to remember is that if I had multiplier divided by a negative, I would have to switch that sign around. Multiply divided by negative, flip the sign. So if I look back at any one of these, for example, if I were to change this here into negative 3, it means I'm dividing by negative 3. This sign would have changed. It would have instead become greater than. Or if in this one here, if this would have been negative 4, I would have had to multiply by negative 4. And again, when I multiply or divide by negative, this would have switched and become less than or equal to. But that doesn't change the entire rest of the problem. The rest of the problem we solve like we normally would, just like an equation. We have to remember that last step at the end. Did I multiply or divide by a negative? Then we flip that sign.